Good morning to one and all present here. As we celebrate our Golden Jubilee year, we extend our heartfelt gratitude and sincere thanks to everyone who has been part of this remarkable journey. Over the past 5 decades, NATPAC has remained committed to excellence in transportation research, planning, and policy support, contributing significantly to sustainable mobility and infrastructure development. This milestone not only reflects our achievements and growth, but also strengthens our commitment to encouraging innovation, knowledge sharing, and impactful research for the future. In this special year, it gives me immense pleasure to welcome you all to the 35th talk of the TransPedia Research Talk Series, organized by KSTSTE National Transportation Planning and Research Center, NATPAC. This talk series is yet another unique venture of NATPAC designed to explore diverse topics from cutting-edge technologies to sustainable solutions. Here we will be featuring eminent young researchers to share their valuable insights for kindling the spirit of future research and development in transportation. Today we have with us Dr. Bhavinlal K, payment expert, Surbana Joran, SMEC, India, Delhi, for sharing his value insights on the topic development of bio-asphalt using rice husk ash, synthesis, characterization, and performance assessment. Now I request Sri Ebin Sanas, Principal Scientist, to deliver the welcome address.
Thank you. NATPAC has launched a technical discussion series called TransPedia Research Talk Series, which is envisioned to promote research for shared benefits by disseminating knowledge on diverse topics from cutting-edge technologies to sustainable solutions. And it provides a platform for young researchers across the globe to connect and interact to shape a better future. Over the past 34 sessions have been successfully conducted, covering a wide array of topics in transportation engineering. Today, the 35th talk in this series will be delivered by Dr. Bhavinlal K, payment expert, Surbana Jurong, India, Delhi. With great pleasure and enthusiasm, I extend a warm welcome to our distinct speaker as well as our ex-colleague of NATPAC who has gracefully accepted our invitation to share insights and knowledge on the topic development of bio-asphalt using rice husk ash, synthesis, characterization, and performance assessment. After the presentation, we will have a Q&A session where you can pose your questions and engage in a meaningful dialogue with Dr. Bhavinlal. Please feel free to participate actively. Once again, I would like to thank Dr. Bhavinlal and extend my warm welcome.
Thank you, sir, for your welcome note. Now I would like to invite Dr. Gautam Sarang, scientist, to introduce the speaker to the audience.
Thank you, Anju. Good morning, everyone. It's my pleasure to introduce today's speaker, Dr. Bhavinlal K, who is currently serving as a payment expert at SMEC India, New Delhi. Dr. Bhavinlal obtained his PhD in payment engineering from IIT Palakkad, where his research focused on the development of sustainable bio-asphalt using rice husk ash for flexible payment applications. He holds an M.Tech in transportation engineering and management from the National Institute of Technology, Tiruchirappalli, where he graduated as a gold medalist, and a B.Tech in civil engineering degree from TKM College of Engineering, Kollam, where he was a best student. Prior to pursuing his doctoral studies, Dr. Bhavinlal worked as a senior hybrid design engineer at Wellspun Enterprises Limited, and after that he joined NATPAC as a project fellow. His research interests include sustainable payment materials and technologies, asphalt rheology, mechanistic empirical payment design, payment performance evaluation, and infrastructure sustainability. He has authored many journal articles and book chapters and holds 2 patent applications arising from his research on sustainable payment technologies. With this strong combination of academic excellence, industry experience, and cutting-edge research in sustainable payment engineering, we are fortunate to have Dr. Bhavinlal with us today. Please join me in warmly welcoming Dr. Bhavinlal for the 35th TransPedia talk. Thank you.
Thank you, sir, for the introduction. Now I invite a distinguished speaker to deliver the talk. Over to you, sir.
Thank you, Thank you, Dr. Gadam sir and Ebin sir and NATPAC. So I believe the screen is visible, right?
Yes, sir. It's visible.
Yes.
Yeah, great. So here we go. So today I would like to deliver my talk on development of Bio-Asphalt using Price's cache, synthesis, characterization, and performance assessment. This was a study and the research is conducted at Indian Institute of Technology, Palakkad, in collaboration with Central Road Research Institute, Delhi. So I have done a PhD on this topic, and I'm very happy to share my knowledge on this to NATPAC team. So currently I am working as a payment expert at Subarna Jurong's Mac SJ. And let's begin the session. So as we know, the asphalt payments, the payments which are constructed using asphalt as a binder, which we call as a conventional asphalt. And however, due to the heavy traffic and climatic changes, the payments are susceptible to more structural diseases like rutting, fatigue, and also it affects the durability cracks like aged induced cracks. And as we know, as a payment engineers, the conventional flexible payment using the conventional asphalt, it is not a renewable resource. We are procuring, producing the asphalt from the fractional distillation of crude oil. So it will cause the resource depletion as well. So these problems associated with the conventional asphalt, various practitioners and payment engineers who are trying to mitigate the problem associated with the existing conventional asphalt, which we are using for the road construction. So finally, they arrived with a new technology and it is called asphalt modification. So asphalt modification is a technology or a tool to improve the performance and durability of flexible pavement which is subject to heavy traffic and varied temperature. So it's not a big rocket science, like we are adding asphalt and we are enhancing its performance for our requirement, and it is termed as a more asphalt. And the past decades, different class of modifiers have been used in the industry and as well in the research experience, like the polymers and the chemical additives. So these are showcasing very high promising performance in the past, and few are already implemented in the site and field as well. The new era came, as we call, is a class of biomaterials. So when we are talking about biomaterials, it is a bio, like it is more environment friendly. I mean, there will not be that much harm to our environment. And why can't we use this kind of material for the road construction? So they have many good advantages, including better compatibility with the conventional asphalt, and it is economic feasible, and it also showcasing very enhanced performance and durability as well. So in this research work, we have been considered Rice's cache as a modifier. And why? Because we have chosen this as a modifier. So quite interesting, right? So as we know, rice's cache, this is we have the rice paddies and we collect the rice and separate the husk in the rice mill. And in the rice mills, like this rice has been used as a secondary fuel for the burning of this husk, and then finally it's as a produced as a byproduct as a ash. So it is like a gray to black color ash. So this ash is somewhat just dumped into the land. There is no valuable purposes on this. They are not utilizing effectively. So this thought came to our picture. Why can't we use as a for the road construction? So also there are major favorable factors, like around 700 million tons it's available in the global production, and it has showcasing very compactability and high performance in the past studies, and it is a very sustainable material as well. So these four core factors led into the utilization of rice cash in the asphalt payments. And we have done thorough literature study. So if you are doing some research study, also obviously we do some the fundamental studies which have been already passed in this particular topic, and we identified some research gaps. These are very critical gaps because the rices cache modified asphalt is not yet implemented on the field. They are in the early budding stage, and the standardization of plenty parameters is not carried out in the past, and the impact of different RHS sources is not carried out, and evaluation of RMA performance and aging assessment and environmental economic implications of RMA. These are the critical four research gaps we identified in our research work, which culminating into a core objective, that is development of rice cash modified asphalt for flexible payment through comprehensive investigation of the synthesis characteristics and structural performance properties. So in order to achieve this objective, we split a different tasks. So the first and foremost, we do actually the literature review and identify what are the past studies which carried out on this particular rice cash modified asphalt. And the second task we have done, like we optimize the blending parameters. And like when we are producing asphalt, modified asphalt, the dosage, blending duration, temperature, shear rate, these are the critical factors that influence the best promising optimized asphalt binder for the road construction. So we are trying to optimize this in our laboratory. And further, we have done the impact of RHS source variation, how different RHS sources are impacting at macro and micro level, which has been carried out in with the Central Road Research Institute in collaboration as well. And further to the impact of RHS source variation, we have carried out the performance evaluation under long-term and short-term aged characteristics. So this will understand how the aging is impacting to the modification. And further, we have done the environment impact life cycle assessment studies and payment design. This will reveal how it is impacting to our environment, whether is it good or bad. So finally, we concluded all the research findings. And in this research work, we have been considered two base binders. One is VG10 and VG30. It showcases different viscosity range of base binders, and three RHA sources, which I have been showcased here as R1, R2, and R3. This we consider from different locations, from the different rice mills. And the aggregates, which we used for the concrete mix preparation. And very curious to share how we prepared the modified asphalt in IIT Learning. We have very high dedicated shear rheometer, sorry, shear homogenizer with us. And this homogeneous, we can control the temperature, time, and shear. And we will be preheating the asphalt, and we will pour the rice cash sample as we desired, and we will prepare the army. So all the preliminary tests have been carried out to cross-check with the standard guidelines of IRC, MOTH, or ASTM standards. And after the characterization of initial testings and findings, the testings we consider the conventional consistency and advanced rheological evaluations using dynamic shear rheometer. We have very high sophisticated and new model of dynamic shear rheometer. We can do the rheology, tribology as well here, and we have done micro level characterization using FTIR, XRDs, XRF, and so on to understand the material properties. So the first we will go through how we optimize the blending parameters. So the outline is like we have developed the experimental design metrics. So that will tell us how many number of experiments that we have to do. And further that we have developed statistical analysis and response showcase how the RJ dosage, shear rate, bending temperature, and duration. And we also have validated statistically. So this is outline of the first task, and we will go through how we have carried out the task. So interestingly, we have designed the experimental metrics for the base binders and different RHA dosages and different combinations. So for each base binders, we have got around 30 number of samples and totaling of 60 RMS samples, and minimum 3 replicates we have done in the laboratory. And we have analyzed how the RHA dosage, how the blending duration, how the blending temperature and shear rate varies however that is impacting the penetration values. Interestingly, if we look into the graph, we can see that all these parameters, when they are increasing, the penetration value is going down. That means our binder is getting stiffened, the binder is getting hardened, and this is easily reflected from the increased softening point as well. So further, viscosity tests also have been carried out. So whenever we are increasing the RJ dosages, the binder getting more stiffened, the viscosity going high, And whenever we are increasing the blending duration from 30 to 60 minutes, it's again increasing. Or if we are increasing the blending temperature, again it is increasing, and shear rate as well. So we can see that if the base binder is changing from VG10 to VG30, according to that also the hardness varies. So VG30 based RMA showcased very high hardness in comparison with the V1 RMA. That is as expected because the base binder is more viscous, right? And further that, we also analyze how it is impacting the storage stability, viscosity, temperature susceptibility, additional to the conventional consistency test result. The storage stability test is, I believe that you might be aware of this test. We will check how our binder and RJ is homogeneous in this. So we will pour different dosages of RJ, and we will take the softening point of top and bottom. We will check the storage stability. If the temperature difference between the top and bottom is very large, that indicates it is not that much storage stable. So we can see I have increased the RJ dosage from 5 to 10. We can see that the delta T, the change in temperature, is increasing. So if the change in temperature is increasing, the storage stability is reducing. However, whenever we are increasing the blending duration and blending temperature or shear rate, storage stability is increasing. So we can use high dosage of RHA at very high blending duration and temperature and shear rate to enhance the storage stability. And further, our interest, we have checked the temperature susceptibility, how when temperature is increasing, how the rate of change of viscosity is changing. This can be visualized using a log-log plot, and observed that whenever we are increasing the RJ dosages, the slope of the curve is reducing, that the curve is getting more flattened. That means the binder has less temperature susceptibility. So whenever we are increasing the temperature, there is not that much reduction in the viscosity in the case of RMA. And this is also represented using a 3D visual plot using response surface methodology to address the interactive influence. And we further optimized using the desirability functions and the constraints which considered as a superior performance, durability, and cost effectiveness. So finally, we developed the ramps and obtained that for the V1 R1 MA base binders, we obtained the optimal dosage of 15 and V3 RMA of 13. And of course, we can see that the blending temperature is almost same. However, the blending duration and shear rate is varied. So these are the optimized blending parameters that we can consider for the further performance analysis and while preparing different RMA samples. And this has been validated using compactability assessment and statistically using residual square error, and observe that very low error values measured from the predicted, and observe that the optimum values are more accurate, and observe the compactability using the cold clock plots. So further to the optimization of the blending parameters, we have checked, investigated how different RJ sources is varying, because we are collecting RJ rices cache from different rice mills. That could affect the performance as well. We can see that R1 and R3 is a little bit darker in color, and R2 is of a more grayish. Let's check how it is impacting. So the outline of this particular task is divided into, initially we have done the characterization of each RHS sources. We check the specific surface area, specific gravity, pore properties, crystallinity, and we further analyze how RHA and asphalt is interacting at the micro level, and performance evaluation, how 3 RHS sources are performing. And then we can identify which RHS source is best. So first and foremost, we have carried out the characterization of our sample. So we can see that this is a graph which is showcasing the pore volume and specific surface area, and specific gravity is right in the right side, and 3 sources R1, R2, R3. So interestingly, we can see R1 and R3 are so for same trend. That means which has very high specific surface area, and which has very less specific gravity, which has very high pore volume. And however, R2 has like some kind of reverse trend, and that is also visible from the pictures, because these two are showing some darker inside. So interestingly, we are getting similar results in the chemical characterization, and we have done some analysis techniques. Observed that R1 and R3, which has very high pore spaces, which is supporting the high specific surface area. And XRD spectrum showcases that the R1 and R3 samples have very amorphous state, which is highly reactive silica into it. The silica of 95% and almost as similar to R3. And if I can summarize all together into a single table, we can see that R1 and R3 also have similar characteristics other than R2. And this is more favorable because it has very less specific surface area and high specific gravity and high pore volume, pore properties and amorphous silica into it. So it could possible to react very easily with the rises asphalt, and it has very pore spaces in R1 and R3. So let's see how they are performing. So prior to that, I have also investigated how at micro level this asphalt and RHA. So when we are adding a for material, it's very interesting. So based on that here,
Sir, hello, sir. Sir, I think there is some issue with the network. Sir, can you hear me? Hello, sir. Am I audible?
You are audible. I think Bhavin is having some issue.
Oh, okay, sir. Okay.
Dear participants, there was a network issue from Bhavinlal's side. He'll be joining back soon. Sorry for the delay.
Hello, am I audible or visible?
Yeah, you're audible. Screen is visible.
Okay, thank you so much. I'm very sorry, some network issues I had in between. Is it visible the screen right now?
Yes, it's visible.
Okay. Okay, so we have done the impact of RHS source variation studies and observed that the R1 sample is outperforming. So R1 samples we have considered for the further evaluation. So in order to that, we have done the comprehensive performance evaluation. So now we are going for the performance evaluation, how we assess the performance of the RMA using based on the optimized branching parameters and RHS sources also. So R1 source only considered for the further evaluation. So I will go to the outline how we have done at IIT Palakkad. So we have done the rheological performance comprehensively, and further we have done the impact of aging, so how it is impacting to the aging. Okay, so further that we have done the retting resistance analysis and fatigue resistance. So these are the critical strains which are associated for any flexible pavement and the asphalt. And interestingly, we have introduced a new hot topic in the asphalt modification. It is called tribology. Tribology is a study of friction. So very less studies have been carried out in the global, and we have also carried the tribology of RMA. And into that, so first I'm going through the rheological properties. So we have considered a different wide range of sea temperature ranges. So basically, as we know, the asphalt is a viscoelastic material, and we are trying to characterize at different temperature range and frequency. So we have considered very large temperature range and frequency, and we have carried out the rheological characterization using dynamic shear rheometer and developed the cold plots. So, and further that we developed the master curves. Master curves are curves which showcasing how our rheological properties varies with the reduced frequency or like the with the phase angles or the stiff complex mold. So into that, whenever we are increasing the RHA dosage, what will happen is the stiffness value, the complex modulus values is increasing. It showcases that the binder is more getting stiffened when we are increasing the RHA dosage. And interestingly, we can see that the phase angle values is going down. That means the binder has more elastic nature than viscous. It is very visible in the cold plots. So whenever we are increasing the phase shift, we can see that whenever this is in the elastic medium and this is the viscous medium. So whenever we are increasing the temperature, the tendency of keeping the more viscoelastic medium is higher in case of modified asphalt. So that means the binder is more elastic than viscous. So let's see how it is impacting the aging further. So aging is impacting the durability of the pavement. So we have done the short-term aging, long-term aging of the material, different dosage for both the base binders. And further, we have also done the aging indices we have been developed and observed that the aging indices values are reducing. So when we are increasing the RHA dosage, all the aging indices are reducing. This is a penetration aging indices, softening point, and viscosity aging indices. So what these aging indices tell to us, showcasing that it has very high anti-aging potential. So that finally replicate the durability of the payment. So Rhizo's cash is a very good material to enhance the durability of the payment, and that we can observe from the release of the aging indices. And further rheological performance comprehensively study how, based on the black space diagrams, this will showcase how it is reacting to crack propagation. So we have the durability cracking. So whenever we are increasing the RHA dosage, however the durability cracking tendency is more, it is not into the limit. So it is safe in the durability cracking resistance, and the block cracking resistance is also reducing, however with this interrange. So it is onset of the block cracking. And we have checked the fatigue resistance. So the material is very stiff material. So the beyond 5% of the RJ dosage, the fatigue resistance is reduced significantly. However, up to 5% is satisfactory. And interestingly, we can see that retting resistance is drastically increasing very high, and block crack resistance is reducing. So all these tell about different type of crack resistance, how our army is performing. And finally, we can conclude that the army has very high block cracking resistance, retting resistance. However, beyond 5%, it is susceptible to fatigue and low temperature cracking. That could be due to its stiffness properties. So, and elastic recovery, we have done the MSCR tests, how it is elastic recover or not. So we can interestingly see that whenever we are increasing the RHA dosage from 0 to 10%, the elastic recovery is increasing drastically. That means it is highly elastic in nature. And the fatigue durability, however, up to 5% it is satisfactory. Beyond that, it is reducing. And as I mentioned before, the tribology is a very new topic in the asphalt modification, and which has its own importance. So tribology is basically a science of friction. So here, it is payment is not all the story of asphalt. It is also with the aggregate. So when we are mixing the asphalt and aggregate, there is a chance of frictional impact between the asphalt and aggregate. How we can study that? We can use the tribology. So we have the dynamic shear limiter, which has a tribology setup, ball on three plate, BOTP basically we call it as. And this is a conventional BOTP, that is steel ball and asphalt. So we will put the asphalt sample here, and we will do the different tribological assessment. So in this our research, why it is more novel, because here we consider only steel and asphalt. We are not constructing the road with the steel with asphalt. We are constructing with aggregate and asphalt. So we developed at IIT Palakkad with new setup. We have developed an aggregate plate and aggregate board and asphalt. And we can see the aggregate plate surface. It is quite natural aggregate, so it has very up and down valleys instead of the roughness of steel plate. So for the past studies, most of the scientists, they have considered the steel plate, but it will not actually replicate the aggregate plate. So that's why we have considered the aggregate plate and asphalt interaction. So that make more sense. And the typology we can investigate using the Stryback plot. So Stryback plot is a well-known plot that we will plot the sliding speed and the coefficient of friction. We are basically measuring the friction between the aggregate and the asphalt using different sliding speed range. So this is the basically U-shaped conventional curve of a Stryback curve, which have different region, and we are more interested into the elastohydrodynamic region where the frictional properties are less. Why we are interested in the elastohydrodynamic region? Because we are talking about asphalt and aggregate, and when we are mixing, we need high workability. If we need very high workability, the friction should be reduced. So we are interested in elastohydrodynamic. And we checked two setup. One is with the conventional setup, that is steel ball and asphalt, and this is aggregate plate and asphalt. Interestingly, the dotted line showcases that the modified model showcasing higher sensitivity towards the normal forces, sliding speed, and temperature. So all things showcasing that when we are introducing the aggregate setup, I mean aggregate plate wall asphalt setup, instead of the conventional steel plate setup for the typology measurement, the results are highly varied. And further, as I mentioned, that we will do the life cycle assessment because our material is a biomaterial. We should have to check how much it is promising to our environment. So we have developed the thorough life cycle assessment studies, and using SEMA Pro software we have, and we developed the workflow, and we have done the inventory analysis, impact assessment, and also we have done the RMA concrete characterization at a lower scale to determine the optimum binder content and the resilient modulus. So these resilient modulus we have been using for the design of flexible payment. So to analyze how the thickness is varying, and based on the total thickness, we estimate the total cost also with the conventional payment, with the RMA payment. Then let's see, this is the final output of the interesting RHA modified asphalt. So it is not just about the laboratory preparation. We will also look into how it is impacting our environment, how we can implement to our site or the field. So that was the motivation behind this life cycle assessment. And the workflow, we have considered 1 kg of RMA. We are preparing 1 kg of RMA, how it is actually impacting our environment up to the market delivery. So that would be like system boundary would be cradle to gate. And we are considering only 15% RHA with and VG10 asphalt. And we are changing, we are just comparing for how much is impacting a asphalt modified with 15% RHA dosage and comparing that with a base binder. So this is a workflow, how we have done life cycle assessment. We have divided into different uh, tasks, and we observed that we have carried out the inventory analysis, how much energy is required, how much water is required for cooling, electricity, and how much is the emission in the crude oil refinery, and how much is the transportation cost, fuel cost, and how much water is required for the cleaning and the rice mill, and all the process, how much is the emission, how much is the resource required. So these are the inventory analysis for a life cycle assessment. And we also checked how much electricity is required to produce a modified asphalt and how much is the CO2 emission as well. And the final output of the life cycle assessment is very interesting and very promising. So we can see that the gray color bars are showcasing the base binder. There is no rises cache into it. So whenever we are adding 15% of rises cache, it has very huge positive impact on the resources. The resource depletion is reduced drastically, and human health is, there is no that much impact on human health, and ecosystem is promising. And however, we can see from all these positive green flags, only the land use has some negative impact. This could be due to the rice paddy, which require more land for the storage. That's why it has somewhat normal acceptable range. However, rest everything is highly promising, and the RMA demonstrate a noticeable reduction in the impact of resource and human health and ecosystem. And further, we have done the RMA characterization at a lower scale in order to determine the resilient modulus. So in order to that, we need to prepare the RMA concrete mix, and we observed that the resilient modulus of RMA concrete is very higher, or 4,500 megapascal, and that is quite promising because the material quality is increasing. That is indicated by the resilient modulus, and also which has a lower optimum binder content. So required binder content would be lower in the RMSE, and it's promising martial stability and flow values. So based on these resilient modulus and material properties, we have carried out the payment design using IIT Pay software, and we observed that the total design thickness. So this is a conventional flexible payment. So when I am using a RMSE in the bituminous concrete, it has 27% of the thickness savings. So that will highly promising. I mean, superior structural efficiency, material and energy efficiency. So total thickness for a given design traffic, we can reduce if you are using a RMSE. And as you observed in the previous, it has very high promising performance, high durability and lower cost. So interestingly, the thickness of the total payment is reduced. So hence we must investigate how it is impacting the economy in terms of total cost of construction. So we have estimated the total cost and observed that the total cost has significantly reduced, and the cost benefit ratio is very higher than what indicate that it has more beneficial advantages. And so finally we are concluding the entire research work as the rises cash modified as well production and its optimization of blending parameters includes like the RHA dosage, blending duration, temperature shear rate, which has significant impact on this hardness, temperature susceptibility, storage stability, and base properties of asphalt impact the optimization. And RHS sources, we observed that R1 exhibit a very high specific surface area, porosity, and pore volume, along with the low specific gravity, facilitating the superior interaction with asphalt. And RJ asphalt interaction is primarily physical, and colloidal stability of RJ increased notably with higher dosages. And the performance evaluation showcase that RJ enhanced the elastic behavior, rating resistance, improved block cracking, aging resistance, and negatively impact the fighting and low temperature cracking resistance. Tribological evaluations showcase that a BOTP system has better represented realistic aggregate asphalt interaction compared to CBOTP system. And the environmental implications and economic impacts of RMA showcase that the life cycle assessment demonstrate lower environmental impact and confirming the sustainability and resource efficiency. And overall, this research work is revealed the holistic characteristics of RMA, covering its production, source impact, performance, durability, and environmental advantages. So, and based on this research, we also identify in future scope that many researchers who are in the asphalt modification or the pavement engineering, they can also consider in the future investigation. The field in blanching of army is required. We need to conduct the field scale blanching in trial section and advanced low temperature performance, because we haven't carried out advanced low temperature. That is a must we need to do. And comprehensive performance characteristics RMAC concrete. So we have done comprehensive characterization of the binder. The mixer level we haven't conducted any sophisticated level of testing performance assessment. That has to be a future scope. And moisture damage and durability studies we need to do, and field implication and long-term performance monitoring also it's under future scope. And also we can also consider suitable softening agent in RMA. So as I said before, I mean the rises cash modified has very high rut resistance. However, it has low fatigue resistance, or it has very low temperature cracking resistance. So that could be due to very high stiff property of the material. We can enhance the softening properties by incorporating a softening agent, preferably a bio-heat. So these are the different critical future scopes that anyone who can interested in this work can do. And interestingly, recently, the Nitin Gadkari, our Minister of Transportation, thought about commercialization of bio-bitumen. So far, we are using crumb rubber modified asphalt or PM polymer modified binders in the field. So they are initiating the commercialization of bio-bitumen in India. So many past other countries which have been already carried out globally, India is starting, and this is very truly motivating us. And CRRI also developed some paddy stable into bio-bitumen. And recently, Union Minister Nitin Gadkari highlights the agricultural waste we can convert into valuable natural resources, and so on. We can travel the road with the bio-bitumen roads very soon. And is it truly inspiring to me and all the researchers, scientists around the globe in the asphalt modification who work in the bio-asphalt. So we have published many international reputed journals, and we have many book chapters and 2 patents filed so far. And I attended many international conference, and also now also attending many conferences. And I should mention my acknowledgement to my team, Dr. Veena Venusaran from IIT Palakkad, and Dr. Shiksha Swarupa from CRRA. It's a collaborative work, and our ASPER team at IIT Palakkad and SMAC SJ team and all the people who have involved in this work. And this is all about me. And thank you so much, NATPAC, and especially special thanks to Dr. Gautam and Ebin sir for giving an opportunity to deliver my knowledge to you all. Thank you all for your patience, and let's see sustainable innovation in asphalt, the road ahead. Thank you so much.
That was nice presentation. Thank you, sir. Now the forum is open for discussion. Anybody have questions or doubts? You may ask.
Bhavin, this is Gautam.
Yeah, yes.
Yeah, it was a very nice presentation. I have a couple of queries actually. Basically, you mentioned about the mix preparation, right?
Yeah.
You prepared the mixture. So you have adopted BC gradation itself. Only the gradation is different, right?
Yeah.
When you
See.
please,
Yeah.
please.
So if we okay. So if the gradation, I mean, if you're talking about the asphalt mixer, so the asphalt mix studies, we have done it very, very low scale. I mean, just to determine the resilient model. So all the entire scope is around 80-90% is a vital characterization. So in order to get the resilient models, we have done the we have prepared the mix in our laboratory. The gradation we have chosen is grade 1, and we haven't done how the gradation of the uh, aggregates impacting the mix properties. That's why it's under the future scope. And so we just considered the BC grade 1. So basically this RMA is a high stiffness, so high rutting resistant mix. So we believe that as per the flexible payment of design IRC 37 recommends that we can utilize the rut resistant mix on the BC and the fatigue resistance on the DBM. So we have go ahead with the BC grade 1 mix for this RMA.
Okay, so that's the reason you didn't use this one in the DPM. Like you want it only on the
Yeah,
resistance.
exactly. Yeah, exactly. So it does not have that much fatigue resistance. So it has very promising rutting resistance. So we consider it in the BC layer.
And one more is like when you prepare this in a large scale, for example, in the field, what kind of challenges you can expect?
Yeah, that is truly interesting question. Like, see, all these stories are into the very quality control laboratory setup. So when we are into the field implication, it is we should also think about how we can prepare the rice as cash. We are not directly taking rice as cash from the rice mills. We are sieving into 75 micron sieve to make it a fine powder and air dried. So that sieving, we need a good setup for the sieving, or a very good work people or any technology we require for the sieving to very micro sizes. And also we required a very good moisture control unit as well. And for the larger scale production, as you said, the quality control is should be very important criteria for developing a binder like this. So once the RHA prepared in the large scale, that might be facing some issues with the quality control of RHA itself. So that technology has to develop, and the mixing unit. So we have developed around 5 kg at a time in a 5-liter container. So if you're talking about very large ton amount of modified binder, we need like a big homogenizer. So, and that should have very high dedicated shear control, temperature control, and time control. The technology has to be procured. I think we can consider how the PMB, that CRMD, how they are producing. Similarly, we can utilize that. And I have carried out some research studies previously that showcase some the people who are working on this RHA modified binders or the production of RHA. They might be have some health issues, like lungs issues during their production, because it is very fine powder. So silica is not good for our human health. So the health also have to consider some precaution we need to take care. And the technology, as I said, mentioned before, the technology we need to develop, and all these are yet to implement. So recently, the Nitin Gadkari, he introduced, we can go ahead with the bio-bitumen. They are starting with the technology, but it is not yet implemented. But they agreed that we do the commercialization. So these are the strategic challenges that could face when we are using for the large scale production.
Okay, thank you, Bhavinlal. Thank you.
Thank you.
Hi, Bhavinlal. This is Srijit.
Hi, Shisa.
Yeah.
How are you?
Yeah, fine. Yeah, this is a good presentations. I have two questions.
Yeah.
And one is like, as you showed in your result, right? When the RHA dosage increases, it is improve the rutting resistance, but beyond the 5%, there is a thermal crackings and some things.
Yeah, exactly.
So my doubt is like when you consider like the state like India, we have the different climatic conditions, right? From there, from the colder regions to the hotter. So how do you optimize the RHA dosage for it? Whether you are considering only for the single dosage or any climatic specific based designs? Or
Yeah.
in the last scope, you mentioned some softening agents. Are you trying for
Mm.
this the out of scope of for this?
Yeah, exactly. So it's very nice. I mean, nice query from your side, sir. So basically, as you said, we are or India, particularly Indian climatic ranges varying according to the region. So if you're constructing a road in Jammu Kashmir, the same technology we might not be used when we are constructing a road in the Rajasthan or in Kerala or somewhere, because the climate is changing. However, currently we are utilizing the viscosity grading system. So we are actually our in India actually looking for the PG grading system. So I hope that you are very good aware of the PG grading. In the performance grading system, we are considering the lowest temperature and highest temperature, which a particular region which satisfies a binder which could perform well. So in my case, we also carried out the PG grading system. So let's see, like when we are adding 5% of RHA into the asphalt, the let's say the PG grading upper temperature is 58 degrees Celsius. So when I'm adding 5% again, it again increasing the 6 degrees Celsius. That means 64 degrees Celsius. So when I'm adding 10%, I can utilize for the region where high temperature region I can recommend. And if you are going beyond any 64 degrees Celsius, I can increase the RJ dosages. And also, as you mentioned about the low temperature cracking, so what we observed is when we are increasing beyond 5%, there is a high chance of a low temperature cracking resistance or fatigue resistance. So when we are increasing the high temperature performance, we are compromising the low temperature performance. That is not a great idea. So I believe that rises cash modified as binders we can use for the high temperature region where the climate is not going less than around 10 degrees Celsius or not. And if we are intended to use rises cash modified as well in a low temperature region, we are including a softening agent into that. So into the rises cache modified asphalt, it could be compromised both the high temperature and low temperature performance. So that is a future scope. For the time being, I can assure that it can perform for the high temperature region very nicely.
Okay, thank you. One is like the basic question, like when you prepared the BC mixture, the temperature is around 160 to 180 degree, right? So how does the
Yeah.
RHA perform under these high temperature? Does it retain its property?
Yeah, exactly. It has it's somewhere because see whenever we are thinking about the temperature impact on RJ, so this rices cache how it actually produced in the rice mills because they are conducting at a very high temperature in range of 500 or 700 degrees Celsius. So that high temperature is already past the material and the material has become very ash. So if you are even beyond 700 degrees Celsius or 800 degrees Celsius, there are no such a great changes in the properties. So, so in the production side, we are going up to maximum 160 degree. So that will not alter any physiochemical properties of rices cache.
Okay, Bhavinlal. Thank you.
Yeah, thank you.
Hello. Yeah, Dr. Bhavinlal. I'm Lekaj from BTRA. It's a nice presentation. You worked a lot on biobitumen. So I have one question. When you are blending this one, is there any there was a cross linking between the rice husk and with the asphalt or the bitumen? I mean, your insights on how the cross linking is happening during the blending.
Oh, okay, yeah. So what happened is, like I haven't. It would be great that I can share the screen and explain. So I hope that the screen is visible, right?
Yes, yes.
Yeah. So what happened is, as we know, the internal structure of a base asphalt. So it has saturates, aromatics, resins, and saturates. So this is a basic fundamental colloidal model of a base asphalt. There is no rises cash, nothing. There is no foreign material, nothing. So whenever we are introducing a RHA, RHA is a foreign material. So let's see like 5% of RHA. So what happened is, this RHA has silanol molecule into it because it has SiO2. So I think I have mentioned that it has very high silicon dioxide, and this silicon dioxide SiOH double bonded, it form a silanol molecule. So basically, when we are adding 5% of RHA, this silanol molecule is highly electronegative in charge, and the nucleus is asphaltene. So asphaltene is any highly electropositive, and there will be high like opposite charges. They will be interact like a, we can say, kind of a electronegative interaction or ion-ion interaction. So that enhance the overall network. So when we are adding 5% to 15%, again the silanol molecule is more, and it is more number of silanol molecules are surrounded by the nucleus, and they form like a kind of a resin like structure. So as we observe, as we also observe that whenever we are increasing the RHA dosages, the resin content is increasing. Okay, so the resin content is increasing. So this resin content is increasing, that's why we have concluding this as a resin like structure. So based on the SARA findings, we developed this the colloidal model. So this is basically not like a crumb rubber modified binder system or a swelling type system. This is just like forming a resin like structure into the nucleus, and they are forming a very high stiff binder. So whenever this base binder is more with the silanol molecule, so that will enhance it the stability as well, colloidal stability. So likewise, it is further enhancing the stiffness. So there is no any kind of the swollen mechanism that we observed with CRMB or PMB here.
So you are saying it was more like a physical bonding rather than a chemical.
Exactly. So that we identified from the FTR technique. We haven't seen any new peaks. So initially we do the FTR techniques to analyze whether it is chemical or physical. So we can see that the spectrum of RHA is showcased like this is along the RHA, and this is the base binder. So in the region where RHA, this is a silicon peak. Okay, so only the silicon peak we can see in the RHA. So this is a this is a VG10 binder. So this is a binder which have different complex material chemical properties. So this is like 5% of RHA. So when we are adding 5%, only this region is getting more peak. That means this is just in adding up. I mean the silicon, the presence of silica just visible in the RMA modified. So there is no phase shifting or disappearance of existing peak. So we concluded that this is just a physical. Then we analyze any colloidal changes is happening. So colloidal changes are happening. So that's why we developed a colloidal model specifically for rises cash modified as well, to showcase how actually it is happening inside into it.
Okay. Thank you so much.
Thank you. Yeah, welcome.
Any more queries? Okay, thank you. Now I request Dr. Sunitha Vijayan, Junior Scientist, to propose the vote of thanks. Thank you.
A very good morning to all. On behalf of KSCSTE-NATPAC, I extend my heartfelt gratitude to each one of you for joining us today for the 35th TransPedia Research Talk on the topic Development of Bio-Asphalt using Rice Husk Ash Synthesis, Characterization, and Performance Assessment. It has been an enlightening section, significantly deepening our understanding of innovative, sustainable pavement materials and the environmental advantages of utilizing rice husk ash in bio-based asphalt binders. First and foremost,
Sri Lakshmi?
Lakshman? I would like to express my sincere thanks to our esteemed speaker, Dr. Bhavinlal K., whose expertise and knowledge have truly motivated our audience. Thank you, Dr. Bhavinlal, for delivering an engaging and informative presentation, providing us with much to reflect upon. We are grateful for the knowledge and insights.
Weighing balance is calibration from BTL.
I also extend my gratitude to all the participants for your active presence and commendable involvement during the discussion section.
You send Lakshman. What is the procedure? There is one
Hello? Rekha sir, can you please mute the mic?
Sorry.
Okay, thank you.
I also extend my gratitude to all the participants for your active presence and commendable involvement during the discussion section, which greatly enriched the discourse. Special thanks to the external participants, including Dr. Sunitha V. from NIT Trichy, Dr. Anjali from NIT Calicut, Dr. Legaj from BTRA, and Dr. Charanya from CUSAT. Finally, I would like to extend my profound gratitude to our director, division heads, and the organizing team for their unwavering support that ensured the smooth execution of this program. I believe that we all have gained valuable insights from today's technical talk, making it a memorable and impactful experience. Thank you once again to everyone involved for your invaluable contributions, and we look forward to hosting more technical talks in this series and continuing this legacy. Thank you.
Thank you. Thank you so much.
Thank you.
Once again, thank you so much to all the NATPAC teams. I was a part of NATPAC in the Calicut office, and me and Ebing sir was there in the initial time, and I was the project fellow over there. I miss all the memories with the NATPAC, and best of luck all the team NATPAC.
Thank you, sir.
Thank you, Bhavin.
Thank you. Great day.